All right, just give us a few seconds for us to set up. I don't really have a joke, but I have like a funny story. So like,
It'd be better than anything we've told.
Maybe. So we came into this hackathon with like a Connect, planning on doing something to Connect, and so we all come from UCR, and another UCR student that came here, we didn't really know him, but he also pulled out Connect. Well, we pulled out Connect, and we were like, this is a little awkward. And it turns out we're gonna do basically the same thing. So we're like, let's just join teams, and yeah, that's Devin. Yeah.
Hey, that was funny. That was funny. Said you guys connected. Oh, now they heard it.
All right, I got a joke.
Don't kill that one. No. We ended it on a good note. All right, go for it.
All right, as long as we're blue screening. All right. So why was the programmer sitting on a bench with his checkbook?
Why?
He was benchmarking his transactions.
All right. So we had a pretty cool presentation, and then it turns out we don't have internet to this computer, so that was really unfortunate. But I guess I'll just wing it. So this is Bender 3D. I'm Ben. That's Devin, Dylan, and Mark, our master sculptor. And essentially, what Bender 3D is that it's a 3D modeling sculpting program that uses the Kinect instead of using a traditional art device like a tablet or a mouse. We're trying to use cutting-edge hand-sensing technology using some new SDKs that we found in order to accurately track fingers and do gestures and things like that. The development of this project was fairly hard. We had to do a lot of things ourselves, especially from a 3D graphics perspective. Had to write our own shaders, had to implement our own object exporter, so we could do some really cool stuff in the future. I'll let Devin talk more about the mathematics behind it.
So one of the interesting issues we had with this is you're going to notice that with the two models we have, they're both completely smooth. It turns out, if you guys know math, that in order to do a lot of these rotational modeling, we have to have it be completely smooth manifold or completely differentiable at all locations, which is, for math and calculus, that's actually really a little bit more difficult than it might sound. Because one of the things that we're doing is if you move the mouse to the center so you can actually see the where it's tessellating the current selection on the parameterization, that in order to not make that be a sharp edge when you're pulling that out, literally you need to have a small radius around the circle, so you're like pulling out an entire edge, much like when you're moving anything in real physical reality. This becomes very awesome when you're like trying to move objects around and do all sorts of cool like objects like how we're doing now. Here, talk about
Okay, that's enough math for one day. So how this works is that we use an API called Candescent, which fits to the Kinect SDK, where if you picture a hand, it forms a contour to your hand for each finger. So we use that to count the number of fingers you have, and we make hopefully it's 5.
They're not discriminating.
Yeah. So and then we use that number of fingers and motion in every axis to make controls and manipulate our object. So hopefully what we want eventually with better technology, we want to like actually make it like a potter's wheel. So as you notice now, the controls aren't really like a potter's wheel. We want to eventually be like using a potter's wheel in using the Kinect, which would be like amazing. And we have a saving feature where we email. We email using a SendGrid API. We were planning to email that to to another server, where and eventually hit a 3D printer where we can print whatever you make here, which would be like the end goal.
All right. So as we can see, what Mark is doing here, he's by far the best out of all of us at this kind of stuff. I'm horrible. If you see me, it becomes like a massive blob really fast. But Mark can sculpt essentially his sphere into a pot. And what we're going to do in the very near future is have you save that pot as an OBJ file. And I had to write that export all by myself, which is horrible. So yeah, but I did it for you, so that you can, so that in the future you can make this really cool base in 3D. And it's like, I like that base, I want that base, and they can print that base, and they can have that base.
All right, thank you guys.
Hustling.
All right.